The remaining reactions of carboxylic acid. The remaining reactions of what? Carboxylic acids. So in that, the first one will be the reduction beta. Okay. So let me see what happened. Reduction reactions of what? Carboxylic acids. When carboxylic acids undergo reduction, they will produce alcohol. So here you have to remember one thing actually. When you oxidize alcohol, for example, I'm taking here alcohol. When you do oxidation of alcohol, what we are going to get? Anybody? When you do oxidation, what we get? Anybody? Complete oxidation with KMnO4, K2Cr2SN. What we get better? Alcohol on oxidation. Anybody? What we get?
Aldehydes and ketones.
Carboxylic acids we get. Complete oxidation. Okay. If you do what Jones something what Tollens what is not for Tollens, Jones reagent, PCC, PDC, isn't it? Pyridine dichromate. If you take what happened, we get aldehydes and ketones, which are mild oxidizing agents. But if you do what complete oxidation, we get carboxylic acid. Reduction of carboxylic acid. What we are going to get? Alcohol. So alcohol on oxidation, carboxylic acid. Carboxylic acids on reduction, we get alcohol. So what I'm saying here, carboxylic acids are reduced to primary alcohol. Here it is primary alcohol. What are the reagents we are taking here? Best reagent is lithium aluminum hydride. Lithium aluminum hydride, isn't it? But lithium aluminum hydride is very costly, expensive it is. So that is the reason what we do, we convert this carboxylic acid into ester. Then ester can be reduced easily by using any reducing agent, right? Now, we can even take diborane also. This is the lithium aluminum hydride, or you can take B2S6 also. We can take lithium aluminum hydride, one of the reagent, or B2S6, one of the reagent. Okay, I'm taking something like this. So CH3, right? CH2, COOH. Now, if I do reduction with what? Lithium aluminum hydride, isn't it? In presence of a solvent. This is a solvent, ether, or B2S6. Or if I take what? B2H6. Now, what is the name of the product? Anybody? What is the name of the product? Now, what happening you observe here? The COOH is converting into CH2OH. Now, tell me what is the name of the product here? Here it is COOH. Now, it will convert into what here? CH2OH. Now, what will be the name of the product here?
Propanol.
Propanol, right? CH3, CH2. This part is R group better. This one thing is actually what? R. It is what? R group. RCOOH. Converting into RCH2OH. Now, this is what R group here. R completed. Next, converting into CH2OH. This is called what? Propanol. In this way, you can write n number of examples. Propanol, n number of examples. Next, we go to what? Decarboxylation reaction, which is very, very, very important reaction for us. Decarboxylation reaction. Decarboxylation. All of you make notes. Don't watch this one. Okay. Just simply what? Don't watch. You write in your notebook by taking this example. Okay. Take this example in your notebook. So what is the name here? Propanoic acid converting into what? Propanol. Next, what? Decarboxylation. Now, what is the meaning of decarboxylation? Removing of carbon dioxide. Loss of carbon dioxide is called what? Decarboxylation reaction. Isn't it? Understood here? Loss of what? If you remove the carbon dioxide from carboxylic acid, that will be what? Actually decarboxylation reaction. Now, what is the reagent we are using for what? Decarboxylation? Soda lime we can take. Soda lime. Now, in this case, calcium oxide is a it is called quick soda, isn't it? Calcium oxide called quick lime we can call. So sorry, quick lime it is called. Quick lime we can call this one. Which one? Calcium oxide. Picked lime we can call this one. It's called what? Picked lime. Okay, and this is called caustic soda. This one is called what? Caustic soda. It's called what? Caustic soda. So collectively it is called what? Soda lime. Now what is the meaning of soda lime? Sodium hydroxide is 3 moles plus calcium oxide is 1 mole. 3 moles of sodium hydroxide, 1 mole of calcium oxide, collectively called as soda lime. Soda lime we can call. This is called what? Lime. Picked lime. This is called caustic soda. Caustic soda we can call. Caustic soda, soda lime. Isn't it? Right. Now, if you take this reagent, soda lime, now what we are losing actually, Na2CO3. You take your Na2CO3, you remove this one. Na2CO3. Now, collectively, now you see Na, Na1, Na2. CO3 remove. Now, one hydrogen is there, no here. This hydrogen will come here like this. This hydrogen will come here like this. Now, what we get here? RH. Okay. So, this is called what? Decarboxylation is a very, very important reaction for us. So, we'll do some exercise on this one now. We'll do some exercise on this one, isn't it? So, we'll take something what? PPT here. We'll see something a PPT here. Before that, what happened? Let me see what happened. If I take what happened, something like this, CH3, isn't it? COONA, if I take. Anybody, if I take what happened, this is not involving beta. It is useful for what? Making the sodium hydroxide, something what? Dry like that, it will use something. Okay, it will absorb some moisture, calcium oxide. So what I'm taking here, NaOH plus calcium oxide I have taken, soda lime I have taken. Now tell me what is the name of the product beta? What is the name of the product?
Methane.
Methane gas isn't it? It is what? Methane gas. I will write some PPT on this one. Let me take something PPT. This is the reduction we completed. Lithium aluminum hydride. Right? Now this one, if you take what happened. Now what I'm saying here, in this reaction, some points are very important actually. Let me discuss this. Now actually decarboxylation, everything we completed. Let me see this one, decarboxylation. Okay, now let me see this one. Soda lime is nothing but the mixture of sodium hydroxide plus calcium oxide is called soda lime. This is the reaction involving, you have seen already this one, right? Now here what I mean to say in this case, for example, if they given CH3 COOH, okay, they want to convert this one into methane. Now what we have to do? Similarly, for example, if they given like this, CH3 CH2 COOH, they want to convert this one into CH3 CH3 ethane, I need to want to convert CH3 ethane. Right? Now in this case, what we have to do? Now first you take NaOH here. Take first mole of NaOH over here. Right? Now what happens here? This H plus and OH minus, they combine, water will be removed here. Now this sodium will occupy the position of the hydrogen. You are going to get here CH3 COONA. CH3 COONA. Right? After that, same process. What is the process we are using? NaOH plus what happened? Calcium oxide. Now what we are going to get? Removing of sodium carbonate. Na2CO3 is removed and the hydrogen is what? Attached here. So we are going to get the methane plus Na2CO3. Now in this way we are going to get in the conversions. acetic acid, ethanoic acid will convert into methane. Now you can do, this is for your homework, you can do your notebook here. Now all of you do this as homework here. First of all, what you are to do, same step, take NaOH, convert this one into CS3, CS2, COO, Na, sodium propanoate, convert this one into sodium propanoate, then we get what? Ethane. Understood one? Everyone understood this one? Because it is very, very, very important. Decarboxylation. Yes. Very important one and very simple also. You practice this one. Today's homework, today practice, you all of you put date today, 3rd December, and practicing what? Decarboxylation reaction 2-3 times, and put this, take this as assignment. Okay.
Sir, can you explain again?
You take beta again. I am taking what? NaOH. See, I am taking what? Sodium hydroxide. From here, I am explaining again. You just observe again. Okay. I have taken sodium hydroxide, and what happens here? In this case, OH minus will be removed. In which? Sodium hydroxide. In this case, H plus will be removed here. Now, H plus and OH minus, what happened? Water will be removed. Okay. Here, H plus is removed. Here, OH minus is removed. Now, this sodium will occupy which position, beta? Position of the hydrogen. Now, what we get here? CH3, CH2, same thing. COO, Na. Right? Next, what we are doing, beta? You are taking what? Soda lime, NaOH plus calcium oxide. Soda lime I am taking. What is the function of soda lime? It will remove the carbon dioxide. It removes the carbon dioxide. So what happens here? You see, everything will be removed like this. Carbon dioxide. Is it visible for you, beta? What I am drawing here, line, is it visible for you?
Yes, sir.
Now, what is removed in this case? Na2, right? Minus Na2. Next, carbon. Next, how many oxygens removed here? 1, 2, 3 oxygens. CO3 is removed. Now, one hydrogen is there, no, here. This hydrogen, this is the hydrogen, isn't it? This is the hydrogen, is now moving to where here? This carbon. Yeah, this carbon. Now what we are going to get here? CH3, CH3. Okay. Now you try this one, beta. You try this one, all of you. Because this I have done, no. Ethane you got, right? Ethane you got. This name is called what? Propanoic acid. Propanoic acid. Right? Now, when you add sodium to this one, sodium propanoate, you have to call this one. Sodium propanoate. You write the names also in your notebook. Right? Now, if I am having what? COOH. Now, how to convert this one into benzene? Is it possible, beta, for you? How to convert this one into benzene? Is it possible? Now, what we have to use, beta? NaOH. First step, NaOH. Second step, what happened? NaOH plus calcium oxide. In examination, they don't give NaOH, beta. Directly, they will give what actually? Directly, they will give what actually? Sodium hydroxide plus calcium oxide they will give, because you can take here 3 moles, you can take, no, and that mole can be useful for this case. That can be useful for this case actually. So directly they will give soda lime only. They don't give first step, second step here. This sodium hydroxide will involve to give this type of product actually, right? Understood, beta? Any doubts still you are having? Because it is very important. Everyone must know this one. Understood?
Yes, sir.
Yes, sir.
Names
Yes,
are
sir.
important, better. Names, if you know only, you can do the examination well. Otherwise, you can't do anything. If you don't know the IUPAC nomenclature, otherwise, what happened? You can't select the answer in that case. So now I will move to what next? Next reaction? Right. Halogenation. HVZ reaction. This is what one of the most important question for 1 mark question, beta. Most important and most easily also. If it is decarboxylation, if it is 3-star question, it will be 5-star question now. So Volhard Zelinsky reaction, simply we can call HVZ reaction. HVZ reaction. In short, we can call HVZ reaction. Very, 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 very important. and very simple also. Very simple also. Now let me see how it is writing in your note. All of you write down beta like this. R in your notebook, write down like this. CHCOOH. And put
This are
beta. Yes, tell me. Is it visible or not? Not visible. Visible or not?
visible, sir.
Okay. Now tell me, this is alpha hydrogen or not? Tell me, because this is a functional group. This is a functional group.
Visible, sir.
Adjacent carbon to the functional group is alpha carbon, correct? Alpha carbon hydrogen is called alpha hydrogen. Understood? What is alpha hydrogen, everyone? Because many number of times I explained here. This is alpha hydrogen or not? Correct or not?
Yes, sir.
Now, take here what? Halogen, X2. X means I am taking here what? Isn't it? X means I am taking here what? Bromine I am taking. Shall I take here bromine? Because X halogen I am taking here. Bromine I am taking. Bromine, Br2. In presence of red phosphorus, you know what? Phosphorus or allotropes are there. Take red phosphorus. Take red phosphorus. Okay. Followed by hydrolysis, everything will be there. Okay. Add some water also lastly. Okay. Bromine, red phosphorus, water. Now what happens here? Alpha hydrogen replaced with bromine like this. RCH, The reactions are not taking place on COOH beta. Are taking place where? Alpha hydrogen substitution reactions on hydrocarbon part here. So what happens? We get bromine. Simple reaction completed here. This is called HVZ reaction. Very important. Examination, many number of times they are asking this question, and very simple also. But most of the students, what they do not, they are keeping bromine here or here something. Like what happened, what first class students, they keep bromine here on here like that. Where we have to keep the bromine here? On alpha high. For example, I am taking one example. We'll take one example. Right, this one. Volhard Zelinsky reaction. Now what happens, you observe here. In this case, shall we take substitution is on hydrocarbon part, you see. Alpha hydrogen are halogenated. They may be chlorinated or brominated. Okay. In presence of what? Small amount of red phosphorus. Okay. This is called Volhard Zelinsky reaction. Now what happened? You see, observe here. I've taken this one. This part, isn't it? This one of the hydrogen is there here. That is replacing with halogen. Okay. Now we'll take some examples here. CH3COOH I have taken. Now I'm writing CH3COOH like this. This is CH3COOH beta, isn't it? So we can write this part actually what? For our understanding, a hydrogen here. This I'm writing as what? 2. Now if it undergo HVZ reaction, what will be the nomenclature beta? Anybody? What is the nomenclature? What we are going to get? Number 1, number 2. Now tell me. Second position, what we get beta? This alpha hydrogen, what we get?
Chlorine.
So what is the name of the product then?
2-chloroethanoic
acid.
2-chloroethanoic acid, isn't it? 2-chloroethanoic acid. You can also call alpha chloroacetic acid. You can also, because on alpha carbon only we are having chlorine, no. So you can call alpha chloro, isn't it? Ethanoic acid. Alpha chloroethanoic acid. Or acetic acid. 2-chloroethanoic acid. 2-chloroethanoic acid. Now, if I do again one more time, second time if I do, first time I have done, second time if I do, what happens? Second is also, how many alpha hydrogens are there beta in this acetic acid? How many alpha hydrogens are there? How many alpha hydrogens are there on acetic acid?
3.
How many? 3 alpha. Therefore, how many times the reaction may takes place depend upon how many chlorines you are substituting. If I take second chlorine, you will get what? Again, one more if you get 2 chlorines. If you get. Again, if you take third time, we'll get one more time here, isn't it? You observe here what happened, how many chlorines you got? 3 chlorine. All the alpha hydrogens are substituted with what? Halogen. So this is called what? Volhard Zelinsky reaction, or simply called HVZ reaction. Only alpha hydrogens will be replaced with halogen. Understood here? Everyone?
Yes, sir.
Yes, sir.
No doubts. Right. Now we'll see something, an example here. I'm taking CH3, isn't it? CH2, CO. This you take as example beta. In your notebook, note down this example. I'm simply writing what? HVZ. I'm not writing reagent here. Simply I'm writing HVZ. So you have to write the reagents. What are the reagents you are using for HVZ? Halogen in presence of red phosphorus and followed by water. Now, if I take this one. Again, HVZ reaction. HVZ reaction. Okay. Now write down the reagent and product here. I'm giving shortcut for you. This is functional group. This is alpha carbon. This is alpha carbon. You cannot get here halogenation. You can't get any halogenation here. Understood? Shall I move to next reaction? Right?
Yes, sir.
Now let me do what next reaction. This is the homework for you. Then take down the homework in your notebook. You can do now itself. No need for what happened after the class. It's very simple. You can place what happened, either chlorine or bromine over here. But it looks simple now. It looks very simple now. But when it come in examination, no, you unable to recollect that. You cannot recollect because you are not, if you don't practice what happened, you cannot recollect. Next, if you go for what? Ring substitution reaction. Ring substitution reactions, if we go, what happens? Let me see this one. Ring substitution means what? Electrophilic substitution reactions. So here, if you observe what happened, this group is just like benzaldehyde. I explained same concept in the carbonyl compounds benzaldehyde. If you recollect that one, it will be easy for you now. CHO. I told you which type of group beta? Electron withdrawing group it is. Okay, electron withdrawing group. Minus mesomeric effect, sorry, minus it is. The minus mesomeric effect group it is. Minus mesomeric effect group. It will withdraw electrons. Then what happens here? At ortho para position, electron deficiency takes place. Now electrophile attacks where? At which position beta? At which position?
Ortho and para.
Meta position, no. Electrophile attacks it because at ortho position, para position, because of electron withdrawing group, electron deficiency takes place. When electron deficiency on oxygen, on ortho and para position, how electrophile attacks? Okay. Now again, I'm saying here one concept. I'm saying here. You remember better. This is very important. You just observe the difference here. Now OH. I'm writing here OH. OH is what type of group it is? Electron donating group. So presence of electron donating group makes ortho and para position negative character. Makes ortho and para position negative character. Now electrophile attacks where beta now? Ortho and para position. Correct? Understood beta? When you have electron donating group like OH or chlorobenzene, isn't it? When you have a chlorobenzene also. When you have a chlorobenzene, which group beta it is? Electron donating group. Now we get at ortho position negative character, para position negative character, again here a negative character. The electrophile attacks where beta? At either ortho or para position. Okay, but para is major, ortho is minor. But when come what happen, electron withdrawing group at ortho position, what we are getting? Positive character. At para position, what we are getting? Positive character. Again at ortho position, what we are getting? Now electrophile being as positive, can it attacks on ortho para position beta? Is it possible? In this case,
No, sir.
electrophile being as positive for electron withdrawing groups, it cannot attack on ortho para position. Attacks at meta because at meta neither positive nor negative is there. Better no. Your meta position, you don't have either positive nor negative. So definitely attacks on electrophile on meta position. Similarly,
Preparation from these are the most convenient method for preparation of haloalkane. In laboratory, in this method, hydroxide group of alcohol is replaced by halogen. In this, the hydroxy group is replaced by the. It is the most convenient method for preparation of haloalkane.
what you are
Haloalkane in the
You're reading
laboratory, it is the
newspaper.
method hydroxide group is replaced by alcohol.
Are you reading
Group
newspaper? What is
alcohol
this?
and
Who is this?
halogen reaction with a
What happened?
concentrated halogen acid,
Who is
phosphorus
what? Who is
halide, and
Vaishnavi Belgaonkar?
iodine chloride. Different reagents are used to get haloalkane and alcohol are described below. By action of acid. By action of acid. By action of acid, haloalkane are prepared by treatment of alcohol with halogen. By action of acid, haloalkane are prepared by treatment of alcohol with alcohol plus तो फिर haloalkane plus water. The rate of the reaction depend upon the nature of alcohol as well as halogen acid. The rate of the reaction depend upon the nature of halogen acid. The reaction of primary secondary alcohol halogen acid requires the presence of catalyst ZnCl2 in which act as a Lewis acid and help in the cleavage of CO bond, whereas chloroalkene are in action of hydroxide acid and primary secondary alcohol are presence of anhydrous zinc chloride in anhydrous zinc chloride groups process zinc chloride groups process.
Sir,
The reaction of primary secondary alcohol with primary secondary
your mic is
alcohol
on.
requires the presence of catalyst which acts as a Lewis acid which helps in the cleavage of CO bond, whereas chloroalkane are prepared by the in action of hydrochloric acid. Chloroalkane
चुप हो जा
माइक कौन है तेरा?
अभी वैष्णवी माइक
किया उसने बंद
सर गुस्से से लेफ्ट किए बे।
ये पढ़ने का स्टॉप ही नहीं कर रही है ना।
तेज बन रहे हो।
रिकॉर्ड हो रहा है।
Chloroalkanes are prepared by the action of hydrochloric acid. Chloroalkenes are prepared by the action of hydrochloric acid. क्यों कर रही है वो? उछलू ना बस।
अरे कोई कॉल करके तो बोलो ना उसको।
मैं कॉल
सर
कर
गिफ्ट कर दी।
उठा नहीं रही।
ऑडियो ऑफ भी किया है।
वो चिल्ला रही है उछलू नकोस करके।
Now, is it visible? Is it visible?
Yes, sir.
Yes.
Yes, sir.
Now we'll just take this last reaction only is there. Let me complete this one within 5 minutes only. Now ring substitution, what I'm saying here, when you have what happened, electron withdrawing groups here. Okay. Now where we get a positive character on ortho position, para position, ortho position, we get the positive charge. Electrophile here is NO2 plus is electrophile. Now compulsory attacks on meta position. You got here what? Meta-nitrobenzoic acid. Meta-nitrobenzoic acid. Now, when you go for what? Halogenation reaction. Halogenation it is. The previous one is called nitration. This is called what? Halogenation. Addition of halogen, halogenation, addition of what? Nitro group, nitration. Now, here also same thing. The bromine is the electrophile. Attacks again on which position? Meta position. You are going to get meta-bromobenzoic acid. So these are the ring substitution reactions of what? Benzoic acid. The ring substitution reactions of what? Benzoic acid. Now it is what? The carboxylic group, the COOH group, the carboxyl group act as a deactivating and meta-directing group. What's the meaning of meta-directing group? The incoming electrophile attacks on the meta position. Now here, the Friedel-Crafts reactions like acylation and alkylation. There is no acylation, isn't it? There is no alkyl, even for benzaldehyde also. Acylation and alkylation is not possible, isn't it? That Friedel-Crafts reactions are not possible whenever if you have deactivating groups, whenever if you have meta-directing groups, this is not possible because they deactivate the benzene. No, they're deactivating the benzene. No, so that is the reason only what nitration and halogenations can be takes place. Okay, so this is about what ring substitution reactions here. Now let me take 12.8. Okay, this is the last thing we'll see. 12.8. Which acid is of each pair show strong acid? Can you say this one beta? In first, which is strong acid beta? Do first. In first one, which is strong acid beta? First one. CS3 COOH. Are you there? CH2F COOH. Which one beta?
Second one.
Acid. This one is fluoroacetic acid. Which one? Second one, no? Right. Very good. Now, because of which group it is beta? Minus I group, electron withdrawing groups always increases the acidic character. This one will be the answer. Now, among these two, I'm writing like this, CH2. Tell me the answer, anybody? While I'm writing, you can say the answer. Because examination, they don't give in this way. They will give in the molecular formula only. They don't give the structure. Now tell me beta, which one is, this is a minus I group and this one also minus I group. And this is an electron withdrawing group and this one is an electron withdrawing group. But which is more effective beta? Among fluorine?
First one.
Fluorine is more effective than the chlorine. Electron withdrawing nature, if you observe what happened, electron withdrawing nature, fluorine is more than what chlorine. So definitely this will be the more acidic nature. Next one, if you observe third one, if you observe what happened, here they given what? Fluorine on which carbon beta? In third one, if you observe what happened, I'm writing here, CH2 fluorine. Next what happened? CH2. 3 carbons are completed. Next COOH. Next one, if you observe CH3, CH2, COOH. Now both the case you are having fluorine is there, but which carbon it is having? On third carbon you are having. Here on which carbon you are having? On fourth carbon you are having. So what I am saying here, if minus I group, electron withdrawing group is near to what functional group? So near to this group, then it affects more actually. Okay, if electron withdrawing group is near to functional group, it will affect more. Now tell me which one will be more acidic nature? Having 3-fluoro
Second.
or 4-fluorobutanoic acid? 3-fluorobutanoic acid. So you may get different type of questions like this here. Okay, and I think this one will be easy for you. This will be what actually? Plus I group, and this one will be what here? Minus I group. So definitely you can give answer. This will be the correct. So you will get questions. Maybe what are the chances of getting questions? Definitely 60-70% you may get acidic character compulsory. That is also very simple. They ask, which are there in the textbook. They are actually asked. Okay, right? Uses, I don't think what happened is very important for you. Just you read that uses here. Okay, right? Next tomorrow class will start what? Nitrogen and its compounds. Okay, tomorrow class will start what? Nitrogen and its compounds. But if you observe what happened here, some exercises are there here in carboxylic acid. This is important beta. Actually, you completed this 12.20. You try this one. You ask tomorrow. I will explain this one. Otherwise, if you want to wait, I can explain this one. To wait, I will explain. Otherwise, what happened? Tomorrow, I can explain this one. Phenoxide is more resistant structure. This one. Okay. Yeah, better I will explain tomorrow, no problem. This is important one. And these are all what conversions beta. We have discussed many number of times. You can do this one, everything. Conversions, you can do anything. Acetylation, decarboxylation, trust aldol is very, this one everyone must practice 3-4 times actually. In your notebook, practice this one at least what happened 5 times. In your notebook, practice because very important reactions. Especially average students, I am saying. Practice this 5 times because it is very important for you. You can score some marks in organic chemistry if you practice what happened. Nemer reactions, Tollens reagent, everything, isn't it? Okay, tomorrow we'll meet again at 8 o'clock. You have any doubts? You can ask me. Only 35 students are joined today. Who are they? Amruta, Anupama, Bujbal, Bhuneshwari, Deva, Harivom, Manjusha, Kiran, Neha M, Neha S, Nidhi, Nikita T, Nishant, Parth, Patiladarsh, Devashish, Pranali, Radhika, Samrin, Samruddhi, Shivani, Shreya, Sneha, Swapnali, Tejas, Vaishnavi Belgaonkar, Vaishnavi K, Vaishnavi SB, Vanita, Varsha, Venkatesh, and Vinayak. Okay, you can leave now. If you have any doubts, you can stay with me. Otherwise, what happened, you can leave now.